For chapter 11, day 5, we're adding in two new shapes. Again, finding the areas of, where we're finding these shaded regions inside the areas. This time we are going to be finding the area of rhombuses and kites. We've already been introduced to these shapes, worked with them in the past. The nice thing about these two shapes is their area formulas are the same. We have a new letter here. Normally, remember, we've had base, height, B and H. We've had R for radius for our circles. And then we've had base 1, base 2. D, in this case, D1 and D2 are the diagonals, just so that you're kind of aware. This would be D1 and then D2, or again, you can flip them. As long as you're aware what D1 and D2 are, that's fine. But they're the diagonals from one corner to the opposite corner, and then D2 would obviously be the other two corners across, okay? So we know our properties. Rhombuses, remember, they have 4 congruent sides. Kites, you have 2 sets of congruent sides. So just as a little reminder there. Let's take a look at example 1. Let's go ahead and apply the formula. Again, D1 times D2 all over 2. So we want to find the measure of these diagonals. Now, what we like to do when we're drawing that measurement is you can see it out here. They put it on the side as to not get confused, because if I put a 25 here, that to me represents the length from here to that edge. Okay, so when we're talking about diagonals, we're going to go ahead and put those lengths out on the outside with a little measuring stick right here, right? But you can notice that these two lengths are the same. Okay, so this is going to be D1. And then the same thing here, this diagonal across, we have a little measuring stick down here at the bottom. If you see this, we can tell that those are the same lengths, right? So the diagonal number 2, we're going to measure as D2 for 11 inches. So you can kind of see here, this formula is almost identical to the triangle formula in terms of just how you calculate it, right? The triangle formula is base times height divided by 2. The area for these ones is D1 times D2 divided by 2. So I like to treat them again the same way. Where I do 25 times 11 first to get my numerator, 275. And then I'll go ahead and divide that by 2 to get our final answer. So 137.5. And again, because we're still talking about area, these formulas for the entire chapter are talking about area, whether you're finding it or using it. Make sure that if you're finding it, your final answer is in the units, which in this case is inches squared. Cool? All right, let's check out example 2. For example 2, the big measuring stick out here, they're giving us the vertical diagonal. So inside, we know this one. That's going to be D1, which is 14 inches. On the inside, though, notice this time, this is, again, there's no measuring stick out there. So this 3 inches is only halfway across the kite, okay? Well, because it's halfway across the kite, we know from back earlier in the year that the kite has the diagonals bisected. So if that's 3, then this one also has to be 3, meaning we can put in our own measuring stick for the full diagonal length of 6 inches, because the 2 parts added together gives us the whole. Now we know diagonal number 2. So we can apply the formula, area equals D1 times D2 divided by 2. Plug them in. 14 times 6 all over 2. That's going to be the 14 times 6 is going to be 84. And then divide it all by 2, you end up with 42. You've heard it a lot. You're going to hear it some more. Make sure area, again, still is inches squared. So the full shaded region we just found there is 42 inches squared. We got to make sure we know the diagonals, the actual diagonals. So that's how we found, we just found the area of a rhombus and a kite. We got 2 more examples. Let's go ahead and check out example number 3. So there's no measuring sticks out here giving us the full length of those diagonals. So let's start off, let's look at what we know. We got a couple things here. This 11 means that we got this length right here, okay? This 3 means that we got this length right here, okay? Now, be careful because this is a kite, right? It's not a rhombus. These two segments are congruent, but this one is not congruent to that one. And you can kind of tell just by looking at them, but just be aware again, because you have a kite, based on those properties, four sides are not congruent. You got to make sure you're not assuming that these two are congruent because they are not. The blue ones are, however. So again, just like before, we can give the full vertical diagonal by stating if they're both 3, then the total vertical diagonal is going to be 6. All right. So now we got to do a little bit more investigating. Okay. They give us this 5 for some reason. That's this length. Well, if I need to find this length to give me this full, we'll put it in purple, to give me this full length, that full second diagonal, we need to find this third part, right? We have to find this third part right here, from there to there. Well, if we just kind of, I'm going to put this back in a minute, but if I white out everything else besides that part that we're looking at, notice we get a nice right triangle. Our properties of a kite state that the diagonals do in fact meet at a 90-degree angle. So just like we did before, leg squared plus leg squared equals hypotenuse squared. And we did this on a previous day. I believe it was back on day 2. Something similar to this. The leg squared, we'll just call it x. X squared plus 3 squared equals 5 squared. X squared plus 9 equals 25. Subtract the 9. X squared equals 16. Square root it. X is going to be 4. So this other part is equal to 4 now. Okay? And we did that through the Pythagorean theorem. Now that we know those, we can take the length here, which again is the yellow, or the purple with the yellow highlight, and then the other part of that to make up the full diagonal now by doing part plus part equals whole. So the 11 plus 4, the total diagonal here is now going to be 15. My apologies, 15. So that's the diagonal 2. Now that we have that, we can go ahead and apply the area formula, which is up top. So D1 we're going to call 6 times D2 is 15 all over 2. When you plug that all in, you get the area is equal to 45. Don't forget we're still in inches, so make sure you label it as inches squared. So problem number 3, we had to do a little bit of extra math using Pythagorean theorem to find that third part so we could actually get those diagonals. For number 4, this was similar to day 2 and then the last problem yesterday that we did on the trapezoids, where they're giving us the full area, right? So they're giving us the fact that this whole thing is shaded and equals 112 inches squared. Nothing has changed yet. Let's go ahead and write out our formula. Area equals D1 times D2 divided by 2. Second step would just be plugging in what you know. The only difference now is we actually know the area. So now we're going to have to be solving for something else. Let's figure out what else we know. Well, we know that this is going to be 7, and because it's a rhombus, we know that the diagonals bisect each other. So we know this other half is going to be 7, making the full diagonal, there's our measuring stick for the full diagonal, 14. So let's call D1 14. D2, on the other hand, they already gave a variable. So we have to solve for D2. So we're going to label that as X. That's going to be part of our solving part. And then divided by 2, that's already given. So if you look back at the day 2, when we had to solve for a variable on a triangle, hopefully you recall that we had to evaluate the fraction. So 14 divided by 2 is going to be 7. So 112 equals 7. X is still there, so times X. And now we just got to get X by itself. We do that by dividing by the number that it's being multiplied by. So divide both sides by 7. And X is going to equal 112 divided by 7, which is 16.